Okay. So let's pick up where we left off. I think we had already scaled well, I was showing you how to scale the ground. We were messing around with this stuff up here, and we talked about transforms. How even the most generic game object comes with a transform, so we can kind of think of anything that's in the scene at the very least has a location, XYZ axis, a rotation, and a scale. And then we have other things that get put on there, and we'll learn about those as we go through this. We'll see some of them today, but you'll see that. So we already stretched our floor out a little bit. Let's see how far they wanted us to take that. So here's the scale on the ground. We're gonna actually have audio.
Now you need to change the scale of the ground plane.
Perfect.
You can do this in 3 different ways. You can select the Scale tool using the hotkey R and simply grab the axis handle you want to change and drag the handle to rescale the plane. You can also click and drag on the title of the fields you want to change in the transform component found in the inspector.
We saw this last time.
Alternatively, you can type a value directly into the fields in the inspector. You can tab between fields and hit enter to confirm your choice. Whichever approach you take, set your X and your Z scale values to 2. Now remember, a plane has no volume, so scaling the Y-axis will have no visual changes unless you go into negative numbers. In this case, the plane, which is a single-sided object, will simply face the other direction. If you place your plane in the scene and you can't see it, check your orientation between the plane and the camera to make sure that you have the correct value of 1 in the Y-axis of scale. This plane is looking good. Now it needs something to roll on it.
All right, so we looked at all that last time. Let's make sure ours matches up what they said. I have mine at 2, 1. I had mine at 3, so we'll match theirs at the 2. I've already thrown my sphere in there, but I was showing you something with game objects. So let me actually just go ahead and dump that. We'll add it when they add it. All right, so this is what things should look like at the moment. Let's see here if I go like that. Remember, if you click on the camera down here in the bottom right, it'll show you like what the camera is currently looking at, and you can always go and, mess with that and try to get the camera to see if I change the camera's rotation, I can change the way I'm seeing the screen, that kind of stuff. All right, so we're a scene. You can pretend to be the cameraman if you click on the camera, and you can aim it wherever you want to aim it. That's kind of the thing. And then same thing with our directional light. If you want to change the position of this guy, whatever, you can do that. All game objects follow this rule, but notice they all have transforms. Okay, so now we're going to drop our player in there. And then we're going to start scripting because we're going to make our player move. All right, because at this point, we're just using the stupid Unity editor. So this guy's gonna, I'm bumping the speed so we zip through a little quicker.
Now that you've created a playing field for your game, you're ready to create a player game object. For this game, that will be a Unity sphere primitive. To create the sphere, in the hierarchy, select the Create menu, and then select Sphere.
We're probably going to look at tags.
Rename the sphere Player. Reset the transform to make sure it's at the origin point of the scene, 0, 0, 0. Either select Edit, Frame Selected in the top menu, or while the cursor is over the scene view, press the F key on your keyboard. This will focus the scene view camera on your new sphere game object. Do you see how the sphere is buried in the plane? This is because both game objects are in the exact same location in the scene, the origin point, or 0, 0, 0 on the X, Y, and Z axis. Now you need to move the sphere up until it rests on the plane, so the player can use it as a playing field. All Unity primitive objects, cubes, spheres, capsules, have a standard size. They are either 1 by 1 by 1 or 1 by 2 by 1 Unity units of measurement. Unity units can be anything you want for your game, centimeters, inches, etc. But default convention used by most people and by the Unity lighting and physics systems is 1 unit is equal to 1 meter. If you raise the player object up by half a unit along the Y-axis, it will be perfectly on top of the plane. To do this, in the inspector, find the transform component. Set the position Y value to 0.5.
0.5.
Great. Now that you've set this up, in the next video, you'll think about the lighting and the scene of your game.
All right, so I'm going to show you a better way to center on this, though. So I'll go ahead and bring the sphere in here. I think we looked last time. There's a bunch of different ways to do this. I tend to just right-click out here in the hierarchy, go to 3D objects, go to sphere. All right, now I'm going to go ahead and name this dude player. One thing that she didn't point out, I'm going to go ahead and point it out now just in case it pops up at some other time. We do have this thing up here called tag. Tag allows us to kind of label objects as being of certain kinds of things, because what we might use this in our code at some point. Let's say we have monsters and we want anything tagged monster to behave a certain way. When we go to look at our game loop, we can ask an if statement. If this game object is tagged monster, not that its name is monster, but if it's tagged as a type of monster, we can make something happen to all things that are tagged that. And there's usually some default things. One of them is typically player, because most games have a player. So it's kind of put some things in there as your starting point. We're not using it yet, so I'll just go ahead and just leave it as untagged. I just wanted to throw that out here. We'll probably be messing with it at some point. All right, so I think she said something about hitting the F key or something like that. You can just double click on the player and it'll kind of zoom in and center that guy. So if you want something to be kind of in the center of the screen, you can just double click it. And then what you can do is you can, wrong gesture. You can then use your scroll wheel or whatever, or just scroll out to get to the right position. All right, I think she was looking at this on the x-axis, so I guess I need to sort of kind of. It's not going to do it. You got this. Well, it's not actually gone. It's okay. There, I think we can. Again, you kind of have to just mess around with this until you learn how to use it. I think once you get into this quite a bit more, using an external mouse will make life easier for dragging stuff around, but I never carry one because then you can do things like with right click and drag it around and angle it and stuff like that. But, you know, pick your poison. I don't think we're going to be doing anything in here overly special that's going to be a major issue. She mentioned that in Unity, everything deals with this idea of a Unity unit. She said the typical thing is in meters. It doesn't matter as long as they're all related to each other. Okay, so right now our scale of our sphere is 1 by 1 by 1 for its scale relative to the default sphere size. What does become interesting is your scale does start meaning something when you get into doing something in virtual reality. Because even if your game looks fine with the normal camera, as soon as you replace the normal camera with what's called the VR camera rig, that's really the only difference between making a VR game and a normal 3D game, is you replace the normal main camera, which is just plain Jane camera, with the Steam VR camera rig or the Open VR camera rig, which effectively is wherever your headset's looking and your tracked controllers. And then you might have new controls, because instead of like pushing keyboard buttons and stuff, you might want to have like the trigger on the controllers and the different buttons on there. But sometimes what'll happen is if you've designed your scene to be a certain thing, you know, maybe your game works well and you're like, I'm going to convert this to virtual reality. You end up putting your dude in there, and either the world is tiny, 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 and you're stomping on everything, or the world's giant and you're like a little ant. Which is kind of fun. So just kind of keep that in mind if you, because what's going to happen is several of you have already started doing this. You're going to follow these tutorials and then you're going to rush forward and start trying to do a whole bunch of other stuff. So I'm going to just kind of give you some things that you're going to run into there, and that scale thing is one of them. All right, so remember right now I'm on my rotation tool. You can kind of see because I have the little circle thingies. Most of the time, we're going to be wanting to move on the probably moving things around, not scaling or rotating. So because this thing is currently halfway in, because they're both at 0, 0, right? Our plane is at 0, 0. Our sphere is at 0, 0. So, and our plane has a height of 1. It's not actually a 1 because it's flat. Planes are flat. They just are single-sided things. But effectively, let's just say it's what the wafer thin. So, well, no, do we get that reference? Monty Python? Too old. All right. So what I'll a lot of times do is I'll just drag it up a little bit and just kind of see where it goes, and how I see, okay, well, it's a little bit too far above. So now I'll just switch this to, which is a not 0.5, not 0.5. All right. And now it's effectively sitting on the surface. So if I were to start my game here, I probably should have checked this out. Okay, we see it. Okay. Now, just to kind of throw a couple things in that we haven't gotten to yet, I'm going to do something here. So I'm going to make sure I have my player selected over here. And I'm going to go over here because I mentioned that game engines, they do all the physics for us, right? All right. So right now, if I look at this sphere, what is he? He's a transform because all game objects are. He's got this sphere mesh thing. That's what makes him look sphere-y. He's got a mesh renderer. That's how we actually view the sphere-iness of the sphere. I don't know what the probes are. We probably shouldn't ask too many questions. Then we have this thing called the sphere collider. We're definitely going to be using that because one of the things we're going to be messing with is the idea of game objects colliding with other game objects. All right. But now we start thinking about, well, if I'm sitting here in the real world and I pull a sphere out, maybe it's a marble or I guess a D1000 would probably be a pretty spherical thing. Yeah. D100s are fairly spherical. I'm going to go ahead and add a component to this. All right. And one of these components is called a rigid body. All right. So as soon as I add a rigid body to this guy, I've effectively said, sphere, you are now a rigid body, which means you are a physical thing. Okay. And physical things are impacted by gravity. Notice this little checkbox here. Gravity is already checked on it. So now if I hit play, oh, I need to turn off the collider. Give me a moment. Okay, there we go. I mentioned we were using the collider, right? Okay, I'm going to go ahead and tell our sphere he no longer is a collider thingy, so he doesn't pay much attention to when he's bumping into other things, but he does have gravity. All right, if we want to see him fall from a little bit higher height, we can throw him up there. Okay, now he's just going to drop straight through the floor and he's falling forever. And if you actually watch it up here, he's still going. I think you hit terminal velocity. It should handle physics, I guess, correctly-ish. All right. So that's something we're going to be messing with because we're going to want actually, I'm guessing she's not going to have us use a rigid body for this since we're just going to use normal colliders. But anyways, when we want our stuff to have mass, we make them rigid bodies. So I'll go ahead and remove that component there. I'll turn our sphere collider back on and we'll put this guy at 0.5. All right. So now we should be back to our sphere just sitting there on the surface. All right. Oh, she wants to mess with the lighting. We'll look at this real quick. We're going to really turbo it though.
You've created the basic elements to start working on your game, but what about the lighting and visuals? If you switch from the scene view to the game view, you'll see that the player game object is lit and it casts a shadow on the plane. This is because all new Unity scenes come with a default skybox and a directional light to represent the sun. Let's tweak this value to adjust the scene a little. In the hierarchy, select the directional light and then review it in the inspector. Change the tint of the light from a yellow to a pure white. Do this by selecting the colored selection square to bring up the color wheel. You can use the color picker to choose a color. To get specific results, it's best to select the exact values. For solid white, set the RGB values to 255, 255, and 255. This is looking much better. However, the gray player sphere is difficult to see on the gray background. In the next video, you'll add some color to the game.
All right, so again, we have our sun, right? We have our directional light here, and you can change things about your directional light. Let's see. Mission. You can change your color. Red dwarf sun. Surface of Mars game. All right, so yeah, you set it to whatever you want, is what it comes down to. If you drag into the upper left-hand corner, you're at 255s all over the place. So if you have a particular color, if you've done web stuff before, you can also throw the hex value in there. If you just find a color you like, whatever. All right, so we're going to have a white floor, I guess. Okay, and I don't know if she's going to just color the sphere. She's going to put a texture on it, so let's find out. Oh, we're going to do materials. Okay. So now we're going to be adding something. We're going to be adding a new component to our assets.
Okay, let's add some more contrast between the player object and the floor plane. To add color or a texture to a model, you need to use a material. This project doesn't use any textures, but we will quickly review what's included in the URP lit material. First, let's create a new folder in our project to hold the materials. In the project window, select the Create menu and then Folder. Rename this new folder
Just human organization, doesn't really
With
matter.
the Materials folder selected, use the Create menu again, and this time, select Material. See how the material was created in the Materials folder? This is because you had the folder selected when you created the material. Rename this material Background. Next, let's change the color of this background material. In the project window, select the background material and review the inspector. In the Surface Inputs section, the first property is Base Map. Select the Base Map's color field to open a color picker. Change the color to a pale gray. You can set the RGB values of 130, 130, and 130 to get the exact shade that the example game uses. The next map represents both metallic and smoothness. As this Unity project does not use textures, you can adjust these independently. First, set the metallic to 0. Then change the smoothness to 0.25 to create a map material. To apply the material to the plane, select the material in the project window, then drag it onto the plane in the scene view. If you drag it over the player sphere, it may try to assign itself there. If it does this, don't worry, use Ctrl or Command Z to undo, and then assign it to the plane. Now the background is ready. Let's create another material for the player. In the project window, select Create Material. Name this new material Player. In the inspector, select the Base Map's color field to open a color picker. Set the RGB values to 0, 220, and 255, which is a nice light blue. Next, set the metallic to 0 and change the smoothness to 0.75 for a shiny finish. Then, as you did before, drag the material from the project window onto the player sphere in the scene view. Great! You've almost finished setting up for the game. But let's make one additional change and rotate the main directional light so that there is better lighting on the player. In the hierarchy, select the directional light and identify its transform component in the inspector. Change its rotation to 50, 50, and 0. This will give it a better silhouette. Now you've created a player game object and a background playfield. Awesome. In the next section of this project, you'll get started with the game functionality and write a custom script.
All right, we are definitely going off script for color here. Pale gray. All right, so punchline here is we're messing with our assets down here, and when we have generic, she mentioned something called textures. So when you play normal video games and the things look good, right? Those are typically textures that give something a very graphical look instead of kind of the pale gray color or whatever. In fact, starting into 3D design, there's actually wrappable textures that'll go around things. That starts getting pretty far outside of my expertise, but I stick with just normal colors. So we're going to go ahead and just create a quick folder. You can call it whatever you want because this has nothing to do with Unity. This is just human organization. We're going to put the things that we create that are materials into this folder called materials. All right, I'll go ahead and go in there. I'm going to right click. I'm going to say I want to create something new. What am I going to create? I'm going to create this thing called a material. You can just quickly look there and see that we have all sorts of other things that we can also create. One of the things in there is an animation. If you want to, you could have multiple like I don't know, multiple like images for like a guy. You want to make him look like he's running, and you can create an animation. Bring all those individual pictures of like, you know, he's standing still, he's got one leg moving, his another leg moving, and then you kind of join them together in the order you want it to play that animation. So it has a nice graphical way of kind of dragging things around for the order. But anyways, we're going to make a material, which is, you call this the ground. All right, so we have the ground. I clicked on that. So base map. What's good? Oh, I do like pink. Wait, before I put that on there. Oh, she wants the ground to be a smooth, right? Oh no, we're going 0.194. We're a rebel. All right. So now she mentioned you can kind of drag the material out here. Actually, usually when you oh, it's my game still running. My game's still running. You can drag the material out here, and when you hover over something, it kind of highlights like what it's going to go on to. Now, obviously, as your game gets more and more stuff going on, it might be a little bit harder to hit the thing you want it to hit. So one thing you can do is you can just click on ground over here, and then you can just drag your material over here to the inspector for it. That way you don't have to hit it pixel perfect on the screen. All right. And then similarly, we'll go ahead and create a second material. What's going to look good on top of pink? Sky blue. Everything looks good on top of pink, I guess. So this is our player. You've probably already figured this out, but I have zero artistic talent. Yellow? Yes, we figured that out. Got it. All right. Well, yellow. Oh, we're supposed to make this shiny, right? Boom.
Oh my goodness.
All right. All right. Oh, that looks awesome. Perfect. All right. So, so do whatever you want. Have fun with it. All right. Then she wanted us to mess with the lighting some. So if I want to kind of. I got it. Come on. All right. Well, I'm just gonna move the light here some, and then we're going to change the rotation of it, I guess, a little bit. Notice as we change the rotation, the shadow changes. So, you know, you do whatever makes you happy. All right. So, you know, light impacts things that are objects there, and it will go around it. Again, something the game engine does for you. All right. So we added colors with our materials. All right. So now we're going to, I assume, start adding some code to this, because we'd like to have like pushing arrow keys and stuff, and for our player to start moving around. All right, so we're gonna get into the coding, blah, blah, blah stuff, I'm assuming. Oh, before you begin, ball and servers early. Oh, we've already done that. All right, so we're going to add a rigid body to the player. The reason we're going to add a rigid body to the players, I'm guessing the way that they're going to do motion here is they're going to add a force, and you can only add forces to a rigid body, kind of like shoving it. All right, so we're going to put our rigid body back on the player. Make sure we get all the right settings for her. But
Now that you've created a player object and a game environment, it's time to think about how the player game object should move and behave. It needs to be able to roll around on the game area, bump into walls but stay on the ground and not fly off into space, and collide with collectible game objects to pick them up. These things require physics. To use physics, the game object needs a rigid body component. To attach this, you need to, in the hierarchy, select the player game object. Next, in the inspector, select Add Component, then search for Rigid Body and add it to the sphere. You can collapse or expand the component view by clicking on the component's title bar. Whenever you expand a component like this, it will also toggle the relevant gizmos for that component in the scene view.
Relevant gizmos, I like that.
Okay, now that the player game object can interact with the physics system, it's time to apply some forces to it. In the next video, you'll install the input system package so you can do just that.
Okay. Come on, you got this. So we'll go ahead and throw our rigid body back.
Now that you've created a player object and a game environment, it's time to think about how the player game object.
Relax yourself. All right. So do I have my game turned off? Let's go back to our player, add our component. We already searched for rigid body and we have it. There's our rigid body. All she basically said after that is, oh, if this is getting too crowded over here, you can minimize these things. Got it? Okay. So we have our rigid body. And that rigid body, she said the reason we're going to work with rigid bodies, and let's get it into the notes here. Oh, there it is. So there's our transform. So now we're going to have something called a rigid body. Z. All right. So this makes a game object. We're going to call this solid. So physics can be applied. Right. So that's what a rigid body is for us right now. And what we're going to end up doing is once we get into the code side of it, which is probably the next video, we're going to have access to this component through a script, and we're going to extract the rigid body aspect of our player, because it's actually going to be that rigid body component we'll be applying forces to. So the player, you can almost think of as a container for these components. All right. And one of the components of this guy that we just added is this rigid body that we can now do things to, physics type stuff. All right, so this is now we come up to the point where we probably find out if you install Visual Studio correctly. All right, do that. Oh, the input system. Oh, is this not going to bypass Visual Studio, is it?
Now it's time to get the player object moving under your control. To do this, you need to apply keyboard input to the player game object, which will act as forces to move the sphere in the scene. You can do this using the input system package and a script attached to the player game object. Unity packages are used to add specific enhanced functionality to your Unity project. To install the input system package, in the top menu, go to Window, Package Manager. You can use the Package Manager window to install, remove, or update packages for your project. Select All Packages to reveal all of the currently available Unity packages. Find Input System, then select Install to add the package to your project.
Let's go do this real quick. So this was under Window, Package Manager. I need to set Unity Registry, I'm guessing. Set the all, their equivalent of all. All right, and then you scroll down to the eyes input system, and you hit install. This is actually an improvement over, well, I'm presuming it's going to be an improvement. The platform back in. Bottom right. All right, scenes have been modified. Hit save. Okay, we're happy. Before we would have had to use a object in code called input to grab and, like the up arrow, the down arrow. We'll see if this guy does something with this. You're going to get this popping up from time to time. It looks like there was a new version since last class. All right. I'm going to skip the new version for now. We can decide if there's not going to be enough changes for it to be a major difference, but I'm going to skip it for now. All right, so I have this guy now installed.
Project. You might see a dialog window asking you to enable the native platform backends for the Unity input system. If you see this, select Yes to fully enable the new system. And then save your changes to the scene. That's it. You've now got the package that you need to make keyboard inputs. If you are creating this game for Windows, there is one more thing you need to do to use the input system package for your game. In the top menu, go to File, Build Settings. You can also use the hotkeys Shift plus Control or Command plus B. This will open up the Build Settings window. In the PC, Mac, and Linux standalone settings, change the architecture to x86_64.
All right, so we need to go to Build Settings. So under File, Build Settings. So we're in this Windows, Mac, Linux thing here. I have Mac OS selected for me. Now, I already have a 64-bit thing for Apple Silicon. So clicked, so mine's probably fine.
Intel 64-bit.
All right, so I mean, for Windows, you want to have Intel 64-bit. I'm on Mac, so it's going to be the Apple processor. So ignore what mine says unless you have a M1 or M2 Mac. If you have an Intel Mac, then you're going to have it say Intel 64. All right, so you want to make sure you have that enabled. And the reason for that is the new input system package must use the 64-bit extensions for your processor. Is that what she said? The build and run? Well, let's find out.
Close the Build Settings window.
Oh.
You'll find out more about this when you've finished making your game. Now you're ready to continue. In the next video, you'll start to use it.
Yeah, build and run is what after you've done your game and tested it and things like that, then you can build the executable. So you can then distribute it as somebody has something they can just double click on in their computer and it runs. They don't have to have Unity installed and all that stuff. All right, so I'll just close this. All right, so now we're going to add player input components. So we're probably going to add a component to our player that sits there and listens to keyboard stuff, is my guess on how this dude's going to work.
Now you've added the input system package to your project. You can use the components that come with it. Let's add the player input to the sphere. First, in the hierarchy, select the player game object. In the inspector, select Add Component. Then, search for and add player input. This will help you get the player movement for your game set up quickly. Next, you need to create an input action.
All right, so let's just get our player input put in here. So we'll click on our player. And that shows us all of the components for player. We'll go to Add Component. And is it called Input System? Player Input. Just player input or player input manager? All right, so that's my player input. So this adds this new component to this dude.
An asset for the player input to use. Player input checks to see if a given action has happened and triggers a notification which can be used by a script to trigger different things in a game. To define the actions that trigger a notification, you need to create an input action asset and link certain keys or buttons to an action name. Luckily, the input system has a default template which will be perfect for this game. Go to the inspector window. In the player input component, select Create Actions. Let's create a new folder called Input.
All right. Create actions. So we're going to have a new folder inside of our assets called inputs. And then inside of that inputs folder, we're going to have our, I guess she's going to probably name it Rollerball.
And save the input action asset there.
Oh,
The player sphere.
She wants to call it input actions. And this is what we're going to how we're going to describe to this new input system what events we want to trigger. For instance, when we press the up arrow, the down arrow is going to scream to somebody who might be listening. We're going to create a listener, and it will update the forces being put onto the sphere as a result.
Still won't move just yet, but you will be able to access the information this component provides about control devices, such as the player's keyboard, using a script to control the player object's movement. In the next video, you'll get started with that script.
All right. Now we're going to actually build a script. We're going to put scripts in a very similar place as we did with our materials. Okay, so scripts are something, let's say you have, if we think about a game like Super Mario Brothers or something like that, how all the little turtle guys all behave identically, right? So you might put 50 of those turtle guys or whatever they're called. I got some other name, but you might put 50 of them in your scene, but you might then attach the same script to all of them because they all behave the same. So when each of them start, it's kind of like they had their own worker bee attached to them, right? And that guy has a run method that says this is what you should be doing, and that's his whole world is running that script. All right, so we're going to be creating our own script here.
Before you create the script to control the player object's movement, let's make a folder to organize script assets. In the project window, click on the Create menu and choose Create Folder. Rename this folder Scripts. Now you're ready to create a new C# script. You'll be using C# as the programming language, as this is what Unity supports. To create a new script, you have some choices. You can go to the top menu and select Assets, Create, to create a new C# script. You can also use the Create menu in the project window. But what might be most efficient in this case is to select the player game object in the hierarchy, and then use the Add Component button in the inspector. The Add Component menu contains the option New Script. You can select this to create and attach a new script in one step. Name the new script Player Controller. Select Create and Add, or press the Enter key to confirm your selection. Unity will create, compile, and attach the script to the selected game object, in this case, the sphere called Player. Creating a script directly on a game object creates that script asset on the root or top level of our project file.
It's a waste of time.
Shown in the...
Right. So she created a folder. Right click here, create folder. Again, just organizational stuff. We'll call this scripts. All right. Now, what she then did is she went to player, she added a component, she added a new C# script, she named it, was a player controller, and it automatically puts it out here at the top level of assets, which means you're going to then have to drag it into here. I'm going to go into scripts. I don't think this is necessarily better, but it's not any worse. So I'm going to say create C# script, and we're going to call this guy player controller. And I'm going to go ahead and click on player. And we're going to drag this dude over here. Oh, did I do it twice? Ninja'd it. There. All right. So there's our player controller script. So it didn't matter which side you did it from, but I don't know why she created a folder called scripts, then had it generate it and put it in another place, but whatever. All right.
project window. To keep things organized, move the player controller asset into the scripts directory you created. Next, select the script in the project window. You'll be able to see a preview of the script asset in the inspector.
I want to talk about this for a second. So when we click this, in fact, I'm going to go ahead, I'm going to double click on this. That should open up. Ooh, untrusted file. Remember my decision. Open. All right, so this is opening it. What is it opening in? Oh, this opened in Visual Studio Code. We don't want that. We can fix that. Give me a moment. All right, so go to Unity. Go to, I think it's under settings. And then is it? There's a place in here where we can tell it what
Under external tools.
external tools. Thank you. All right, so under open by file extension at the top, external script editor, we want to choose Visual Studio. For me, it's Visual Studio for Mac because that's what got installed when we installed Unity. So make sure you choose that. Otherwise, it opened up in Visual Studio Code. It's not a big deal either way, but Visual Studio for Windows, Visual Studio for Mac, it'll do, presumably, it'll let you do extensions. When you say dot, it'll show you the list of all the things it knows how to do, where code actually probably can be configured to do that too, with a plugin or something. But we're going to choose Visual Studio for Mac, and we'll just leave the rest there for now. Notice you can also do that for images and things like that if you want a very specific program to open when you mess with images, and we'll burn that bridge later. All right, so now when I double click on this, it should open up Visual Studio. So he's cooking down there. And this should be, well, at least for a lot of you, this is going to be your first time seeing a C# script. And we want to look at the similarities that we see here between C# and Java. This guy's upset about something. Oh, there's an update. I'm just going to ignore it. Yeah, good call. All right, let me hide that. All right, can I make this bigger this way? Yeah, there we go. All right, so first of all, we're looking at a C# program. This is a default script for Unity. First of all, right up top, you see we have classes just like we have in Java. This class is called player controller because that's what we named our script. You can read this colon thing here. That's the same thing as extends. It's its inheritance. All right. So a player controller, he's a normal C# class that we're inventing, but he gets everything that comes from this thing called mono behavior. And mono behavior, this is actually left over from before they started using, had a partnership with Microsoft with Visual Studio. There is a program called Mono for writing C# code cross-platform. So whether you're on Windows or whether you're on Mac or Linux, it allowed you to do non.NET stuff with C#. So this class has been around for a long time, even though now we use the Visual Studio editor. Doesn't really matter. It's just that's where that naming comes from. But a mono behavior is the default behavior for scripts, and it comes with a couple of things by default. You can think of this start function as kind of like a constructor for a thread. Okay, almost think about this script like it's a thread, like we've recently talked about. So start allows us to initialize the stuff associated with our particular game object that this guy might be attached to. And all this stuff just happens one time when the thing first launches. Update, this is kind of like your run method. Anything we put inside of update updates every single time a frame happens in your game. Now, there's another function called fixed update. I bet you, hopefully if we have this thing set up right, fixed update. So if you just start typing in fixed update like that and put it in, it'll go ahead and complete it. Fixed update works a lot like update, but what it does is it standardizes your frames per second to 60. This then becomes kind of a game programming decision that you make as the developer. If you want to say, look, everybody who's playing my game has to have a good enough graphics card to at least play it at 60 frames per second. If I do that, there might be somewhere we can change the fixed update setting for an individual game to less than that, but the default, I believe, is 60. But if you assume that, okay, everybody has a good enough graphics card to play my game at 60 frames per second, and I don't want people with faster graphics cards to have an unfair advantage, I can use fixed update, which means everybody will have things updating in the game kind of at the same rate, unless your graphics card's crappy enough that you can't keep up with 60 frames a second. Okay, so when you use fixed update, this guy will get called at most 60 times per second. If you use just update, this guy will get called as many times as it possibly can, once per frame in a second. And a frame, you can think of it as just a picture on the screen. And you put a whole bunch of pictures on the screen right next to each other really, really, really fast, and you have a video game. that's the deal. All right. For us, it's not really going to make a difference. Just that's the difference between fixed update and update. All right. But for us, what we want to think about is this is like a threads constructor, kind of like the constructor we had for worker bee. Get everything set up in here. Thank you. Thank you once again. All right. So this happens one time when this script first launches per component or per game object the script is attached to. Update gets called every single frame. So this is like your run method inside of your thread. Okay. So our player controller class is a mono behavior, and mono behaviors, among other things, automatically get this guy called when they first launch. They call it once, and then automatically call that guy every single frame. So we can take advantage of that. But it also requires some knowledge, because we don't want to do stuff inside of update that might take too long, right? You probably don't want to do a 5-minute authentication thing when this thing's getting called 60 times a second. So put stuff inside of update that happens fast. All right, make some sense? All right. Again, I'm not going to give it to you as homework because I want to get through this tutorial. Feel free to jump ahead, mess with it, see what bugs you have with your code and stuff like that. Keep working through the tutorial. We'll come back and get our guy moving on Monday. Remember, I did mention that the midterm will be next Friday during class time. I will have it online, so it'll be on Blackboard, but the way Blackboard's, I don't know, anti-cheating crap or whatever, it makes me set a fixed time that you have to take it or whatever. So in any case, a couple of you contacted me that you need to take it at a different time. We'll figure something out. All right. But remind me at the beginning of class on Monday, I'll talk a little bit about the exam format, yada, yada, yada. Who? No. Only stuff that we did up to, but not including Unity. Okay. All right, everybody, have a good one. Have a good weekend. Questions, comments, concerns, bribes. I thought maybe I'd already said it. Did I not? No. Yeah. Disappointment.